Hello, and welcome to the Air Force Institute of Technology. My name is Nicholas Hamilton, and I'm a major in the United States Air Force. I also teach classes here at the Air Force Institute of Technology. Today, for Engineers Week, we're going to look at flight. Now, flight is something that has always fascinated me. It just amazes me how simply birds can take to the air and fly around, while we as humans cannot, at least not without some help. So today, we're going to do some experiments on flight using paper airplanes. We'll do a look at 3 different types of paper airplanes. We'll form a hypothesis about which one we think might fly the furthest, then we'll do some experiments to determine which one actually did fly the furthest. So come on, let's go take a look at this experiment. We'll start with the simple dart type airplane. You'll need an 8.5 by 11 sheet of paper, like this one. We'll start by doing a simple hot dog fold down the length of the paper. Then make sure you press down on that fold really well. Next, we'll open up our paper. Then we'll fold the top right corner and the top edge along that right edge there to the middle. And make sure it's flush with that center fold. Once it is, we'll press down on this fold to make sure this fold is tight and secure, like so. Next, we'll do the same thing for the top left corner. Next, we'll take the right edge again and fold it to the middle once more. We'll also do this for the left side. Next, we'll fold our plane in half again. Then we'll fold one flap out. And then we'll fold the other flap out. And these 2 flaps now are going to be our wings. And this is our simple dart aircraft. Our next aircraft will be a stub-nose fighter. Once again, we'll start off with an 8.5 by 11 inch sheet of paper. But this time we're going to do a hamburger fold instead of a hot dog fold. Once again, we want to make sure our fold is nice and secure. Then we'll unfold it. Next, we're going to fold our top right corner in nearly to the middle, but not quite. Then we'll do the exact same thing with our top left corner. Then we'll fold in again to the exact same point on the right side. Then we'll do the same thing on the left side. Once again, we want to make sure we get really good creases and really good strong folds here. Next, we'll fold the nose in a little bit. Then we'll fold our paper airplane in half. And then we'll fold out the wings. We want to be sure that we fold out the wings about the same amount. And this is our stub nose fighter. For our third and final aircraft, I'm going to do a special kind of aircraft that I call a fry cut plane. Once again, we start with an 8.5 by 11 inch sheet of paper. This time we're going to fold it a little differently. We're going to fold this corner over to here and make these two edges of the paper flush with one another. Once these edges are flush, we'll go ahead and secure this fold by pressing down on it and creasing it, making sure we have a really good secure crease. Next, we want to remove this strip of paper that's at the bottom of our edge that we folded down here. We can do this by cutting it, or we can do this using another method that I like to use to tear it off. To tear it off, we'll start by flipping it over. So we're looking at the back now and folding this piece up. We'll make sure we fold this corner so it's even with the bottom edge of the paper down there. And then we'll also make sure it's even at this edge over here. And then we'll work from this corner over, making sure our fold is even with the bottom edge of that paper that we folded over. And then we'll secure this crease by pressing down on it firmly. Now we're going to unfold this and fold this little flap of paper at the bottom over the opposite direction and crease it again. We're going to flip it over and crease it the opposite direction again. And we'll do this one more time, folding once again the opposite direction. Now by doing this, repeatedly creasing the paper in opposite directions on the exact same spot, we're weakening the paper so that it should tear easily without ripping up the paper that we'll use for our airplane. Now we want to remove this flap by gently pulling on the right edge corner here, while at the same time holding down the part that we're going to use for our paper airplane with our left hand. You can gently pull down on this and slowly tear it without totally destroying the piece of paper you want to use for your airplane. Now we can discard this piece. Next, we want to fold this corner to the center, right up to the edge of that crease that we already have in the middle. Press down on that fold to secure it, and we'll fold it over again. And we'll fold it over one more time. Now the next step is we want to make sure that we have a nice curve to our airplane. So what we're going to do is we're going to hold this corner and we're going to pinch this paper with our fingers and thumb and pull up on this corner here while pulling the paper through our fingers. This is going to start to give us a curve to our airplane. We can also go the other direction as well. Now we want to tuck the corners into each other. And now we have our nice circular fry cup airplane. So now it's time to form a hypothesis. In this case, the hypothesis you're going to form is which aircraft you think will fly the furthest. Do you think the aircraft that will fly the furthest will be the Simple Dart, the Stub Nose Fighter, or the Fry Cup? Now that you have your hypothesis, let's go test these three aircraft to determine which one really will fly the furthest. Now you might be thinking, how did the fry cup come in first, the simple dart in second, and the stub-nosed fighter come in third? Now, as every good scientist knows, you can't determine the correct result of an experiment simply by doing one experiment. You have to do several tests. The reason for that is, there are so many different things that can go wrong or right or change and vary the results of the experiment from one experiment to the next. So instead what we do is we do several experiments and take the average result of all those experiments in order to determine what the true correct result is. So instead of just doing this one test, we are going to do 9 more tests on each of our aircraft, so we have a total of 10 tests, and then we'll determine which aircraft on average flew the furthest of the 3. Going back to where we left off, we'll start by marking the final locations of our 3 aircraft from our first test. We'll mark the location of the simple dart in red, the stub-nosed fighter in blue, and the fry cup in green. We'll also mark the start location with white. Now we have completed all 10 test flights for all 3 of our paper airplanes. We made sure to mark the point at which every single flight landed. Next, we need to measure how far each plane traveled for each flight. Fortunately, the carpeted floor tiles are exactly 2-foot squares, so it should be easy to add a ruler to this image to roughly determine how far each plane traveled on each flight. Let's go ahead and draw our ruler now. And now we will remove the image so we can just measure how far each plane flew each time. Since we do not have a very precise method of determining the distance each plane flew, we will round the distance to the nearest 2-foot marker. Then we'll compute the sum of the distances of all 10 flights, and then we'll divide by 10 to compute the average. Now we can see clearly that the Simple Dart came in first place, the Fry Cup came in second, and the Stub-Nose Fighter came in third. Hey, so we just completed our experiments. Now, after those experiments, go back and look at your hypothesis, your theory as to which aircraft you expected to fly the furthest. Was it the Stub-Nose Fighter, the Simple Dart, or the Fry Cup? And did your hypothesis meet the conclusion we reached as a result of this experiment? Now, consider different ways we could vary the experiment to determine which other paper airplanes might prove to fly further or better than the others.